Okay, I think we'll make a start and get underway. So hello and welcome everybody to our latest webinar, How to Specify Lighting for ANPR or LPR Systems. My name is Callum Ryder. I'm the marketing manager here at Raytech. I'm also the product manager for our transport products, which obviously we'll be talking about or in relation to today. The webinar should last around 25 to 30 minutes for the main presentation. We will leave some time after that for questions at the end. Just to say that the slide will be made available after the webinar, and we'll send a follow-up in the next few days with a copy of the slide and a recording, so you can watch back and catch up if you wish. As I said, questions will be at the end. I'm joined by my colleague who will be joining us for the Q&A at the end, Alice McCoy, one of our regional sales manager. So he'll be joining me for the Q&A to help with any questions. You can type those questions as we go through. You should see a question section on your control panel where you can type questions in and submit them as we go through, or you can type them in and submit them at the end. But like I say, we will be saving some time for questions at the end, so we'll do our best to cover as many of those as we can. So that's, I think, all the housekeeping rules done. So without further ado, we'll move on and make a start. So quickly just go through an agenda first of all. So I'll start by giving a quick introduction to what ANPR or LPR is, and just to mention now at the start, that's probably throughout this webinar, I'll be mainly referring to it as ANPR. It really just depends on where you're from and whether you refer to the plate as a number plate or a license plate. I can see in the attendees list, we've got quite a few on from North America who will probably refer to it as a license plate, but over here it's mainly number plate. So just to set my stall out from the beginning. We'll then look at why do we need lighting for ANPR, what is the purpose, why do we need it, and then we'll look at some of the key considerations that you should take into account when specifying lighting for an ANPR system. So looking at things like the wavelength of light, the difference between constant and pulse illumination, the pulse settings which are available to configure, and the illuminator specs as well, which you should take into account. And last of all, we'll cover how Raytech can help and talk you through some of the products and the ways that we can help you for ANPR projects in the future. So we'll start with this introduction to ANPR. So what is ANPR is a good question to start with. So it stands for automatic number plate recognition, or LPR license plate recognition. And at a basic level, it's being able to capture the details of a vehicle's plate and then being able to do something with that information. And we'll touch on some of the things and the different systems do with that information and the reasons or uses for capturing the plate in the next couple of slides. But it's important, I think, to start just to be able to distinguish between the terms capture and recognition. These are two terms which come up quite frequently when relating to ANPR. Certainly capture is a term I'll use quite a lot today. And when we refer to that term capture, we're talking about that basic level of enabling a camera to obtain a clear quality image of the plate. Recognition, on the other hand, refers to the intelligent software process of reading, recognizing, and then analyzing those captured images. But with that in mind, an ANPR system plays a vital role in a wide range of intelligent transport systems. We've got some typical examples in these images on the screen. So car park access on the far left. This is a project we were involved with at Heathrow Airport a couple of years ago. Speed monitoring systems. Anyone who's on from the UK will be familiar with the average speed check cameras that you can see in the shot there, which just about shot as a bank of our white light products. And in even more advanced systems such as driver recognition or mobile phone detection systems, although there may be a further end goal beyond and more technology used as part of those systems, there still is a requirement to capture the vehicle's plate, and without that ability to capture the plate, the system would not operate. So as you can see, the use of ANPR systems is important for a range of sometimes basic, sometimes advanced intelligent transport systems. So with that understanding, there's and the knowledge that there's a variety of different systems, I think we can summarize 3 main objectives which each system is likely to have, and some of the goals behind ANPR systems existing. So one could be to deter crime. So even the presence of an ANPR system can be enough to deter crime. And it's also used for prosecution reasons as well. So such as those average speed check systems that we showed in the previous slide. And that's why good quality images of the plate are so important and why the system must be reliable, because if you're using it for prosecution services, it needs to be effective, reliable, 24 hours a day, 365 days a year. And ANPR is also used to facilitate access, so whether that be car parks, toll roads, high occupancy vehicle lanes, and so on, whatever the purpose of the system or whatever it's there to do, all these different types of systems have in common is that for them to work successfully and reliably, the quality of the image is critical. So during the rest of this webinar, I'm going to be focusing on the lighting requirement for ANPR systems. So firstly, why it's needed, and then later we'll look at the things you need to consider when you're specifying lighting for ANPR applications. So the importance of illumination. As I've already stressed, quality of the number plate image or the license plate image is the most important factor. It is the key to any successful ANPR system, and every aspect of the installation should, in theory, be designed with this in mind. Critically, the amount of light determines how an object appears to the camera, so we can appreciate how important it is to consider dedicated lighting as part of your ANPR system. And for more advanced systems, where intelligent processing of the plate is required, the quality of the image and the importance of using dedicated lighting becomes even more important, even more critical. And that's because these systems rely more heavily on the quality of the image than perhaps a more basic system does. So the more advanced the system, the more important the quality of that image of the plate becomes. We also have to take into account the fact that there are lots of challenges associated with capturing the plate, and to overcome these and ensure consistent, reliable images are captured, lighting plays a really important role. So let's firstly consider what these challenges are. Firstly, weather and ambient light levels. Now, these will obviously vary depending on where in the world the ANPR system is located, but it can also change on a daily or hourly basis, especially if you're in the UK with the weather that we get. But we must be able to capture the plate, whatever the weather, or whatever the light levels are. Car headlights are another issue which can fall into this category and can make it difficult to capture the plate. And again, we'll talk about how lighting can help overcome that. Secondly, dirty number plates. So when vehicles are out and about on the roads, they will invariably become dirty, which makes the plate harder to see and again puts more strain on the ability of our ANPR system to get good results. And lastly, and possibly most importantly, we also contend with fast moving vehicles. The faster the vehicle, the faster the shutter speed you will need on the camera. And you may also decide to do things like using a higher f-stop to improve the image. Both of these factors will restrict the amount of light which reaches the camera, and it makes it harder for the camera to capture the plate. So that again stresses the importance of using good quality dedicated lighting to help assist the ANPR system. In terms of the type, let's go back this one slide there, sorry. In terms of the type and quantity of light, this will depend on each application. What we can say for sure though is that the lighting plays a really important role in creating an effective system. So moving on so we've covered why lighting is so important to ANPR systems now. So we're going to look at the key factors to consider when specifying an illuminator, starting with the wavelength of light. So we look at 2 or 3 different wavelengths of light. We'll look at the characteristics of each wavelength and then how it can be used for an ANPR system or an ANPR application. So we'll start with infrared, and specifically 850 nanometer infrared light. So Infrared or IR provides the camera with monochrome images. These are the characteristics of infrared. It's not visible to the human eye, although there is a faint red glow when looking directly at the illuminator. In terms of radio techno security background and the use of IR for CCTV systems, we would generally describe 850nm infrared as semi-covert. So what does this mean in the context of an ANPR system? So firstly, a monochrome image would generally be sufficient. It provides the images, well, providing the images are clear and are of high quality, a black and white or a monochrome image would be sufficient. Because the light is not visible to the human eye, it means it doesn't distract the driver, and they will not be aware of it or not distracted by it. While IR is not visible to the human eye, cameras are very receptive to it, and that helps in being able to obtain high quality images in assisting that camera in being able to do that. The use of IR also helps to overcome issues with headlights or glare, because it allows the opportunity to filter out the visible light, which is no longer needed to capture the plate. And for these reasons combined, IR light is the preferred wavelength for the vast majority of ANPR applications or ANPR systems, and we would always recommend using IR at 850nm where possible. But that doesn't necessarily mean that IR is the only type of light suitable for use in ANPR applications. So we'll take a little look now at white light. So not that I really need to explain the characteristics too much, but obviously white light can provide the camera with color images, and it's also highly visible to the human eye. So again, let's consider this in the context of an ANPR system. Well, it can be of use if we need to identify the color of the plate or colors on the plate. Number plates vary dramatically from country to country, or as I said, we've got quite a few of our attendees on here today from North America, so you will know that plates can vary by state to state as well. So capturing color may well be a requirement if there is color on the plate. And in a similar vein, we may need to identify the color of the vehicle as well as the image of the plate, or indeed there could be other lighting goals which stipulates the use of white light, or that white light is required to capture color images. On the downside, it could be distracting to the driver, the use of white light, because it's visible to humans and the human eye, unlike infrared. And it is harder to achieve results with white light. The camera is not as receptive to white light as it is to infrared light. And it also means that we can't filter out the visible light, so things like headlights and glare could become more of an issue when using white light for your ANPR system. There are other wavelengths of light available too. At Raytech, we've experimented and tested quite a few over the years. On the right is an image you can see of us doing that with some 730nm, some 730nm light, also referred to as far red. And that's perhaps the most common other type of light used in transport applications, but generally this would be used specifically for seeing inside the windscreen. And we have actually done a separate webinar on that a year or two ago, which is available on our website if that's of any interest. But generally, the use of 730nm wouldn't be used for the sole purpose of capturing the plate. As you can see from the image there, it just give off a distinctive red glow with the illuminator positioned just on the shutter of the exit there. So now we're going to move on to two different types of light that can be considered for ANPR systems, constant and pulse light. I will say that Raytech offer both of these types of light, so we're completely impartial when it comes to recommending which is best for an ANPR system. So we'll do our best to give you a bit of insight into the two types. And we'll start with constant light, which is well, most people will be familiar with constant light. Constant light is lighting which is switched on 100% of the time, and this means that it's constantly available for the camera, and the camera can constantly take images. It also means that no trigger is necessary to initiate the light, because it's always switched on, so it doesn't need anything to turn the light on or turn it off. It's always there. We have just got a quick graph which demonstrates this. So the vertical axis on this graph refers to the intensity of the light, and the horizontal axis to time. And as you can see, the light remains on. There's a constant horizontal line to stipulate that. But this will perhaps have a bit more meaning when we come to compare it to pulse light and how that looks in terms of a graphical layout. So we'll refer back to a similar graph later on when we look at pulse light. So just flipping back to the previous slide for a second, just a couple more bits to cover. I think perhaps one of the advantages of using constant light is that it makes setup and maintenance easier. There's certainly less to consider in terms of the setup when you compare it to pulse light, and again we'll cover that. That'll become more evident as we cover the later slides. But I think the key takeaway to have from this is that while constant light is switched on permanently, an ANPR camera is not constantly capturing images. ANPR, by its nature, tends to be event-based, i.e. when a vehicle passes a speed check camera or a car approaches a car park barrier. So they are all event-based. The light is not, the camera is not constantly capturing images. And this leads us on quite nicely to talk about pulse lighting. So with pulse light, the light is only initiated when it's required. We refer to this as a lighting pulse or a strobe, depending on the terminology you use. And to do this, the illuminator needs to be synchronized with the shutter of the ANPR camera, usually via a TTL input. This is all made possible due to the fast switching speeds of LEDs, which isn't available with traditional technology or existing technology prior to LEDs, but the LEDs are more than capable of doing this. But the question you might have is, why would we go to the effort of pulsing the light when we could just use constant light if that was easier to set up and it's more straightforward? Well, we'll run through a few of those reasons now. Critically, the use of pulsed light allows us to generate far more light. Use an example: if the camera shutter is only open for, say, 1 millisecond every 50 milliseconds, then the camera shutter is only open for 2% of the time. Because the LEDs are therefore being used for only a fraction of the time compared to a constant light illuminator, this means they can be overdriven and able to deliver far more power than a constant light illuminator. Typically, overdriving LEDs can deliver as much as 3 to 5 times more power from the same package as a constant light illuminator. So this can help deliver longer distances or brighter lighting at the same distance, but overall with that purpose of enhancing the image quality and making the system more effective. And because when we're pulsing the light, the LED illuminator is only on for short bursts of time, it's actually switched off for much longer periods than it is on. So this can help to significantly reduce overall power consumption too. And if power saving is the primary focus of the setup, I'm not saying it always will be, but for some applications there may be one of the primary focuses to save power. You could actually reduce consumption by as much as 95% if LEDs are pulsed without overdriving, so running at the same power. But if you did want to generate that more power, even when you overdrive LEDs by 5 times the pulse power, you are still saving 75% compared to constant light illuminator. So there's big opportunities to save energy consumption and costs through using pulse light. In the same token, with the illuminator being dormant for far longer periods than it's switched on, pulsing can actually prolong the life of the illuminator. It will run very cool when compared to an illuminator using continuous mode. It can be a good solution for applications with a high ambient temperature. And finally, pulse lighting also brings new opportunities with the illuminators being highly configurable, so they can be tailored to the needs of each application. And this is something we'll cover in more detail in later slides when we look at what functionality pulse lighting gives us. But before we do that, let's go back again to the graphical layout of pulse light, and we'll take a look at the graph again, but this time with pulsed rather than constant. So looking at the red line, you'll remember the constant one being a consistent horizontal line across the graph. But with pulse, you can see that there's a spike or a pulse in the line, and that's basically the light only initiating when it receives a trigger from the camera, which is signified. So that trigger is signified by the grey line above it. You'll notice a few different labels on this graph too, such as the trigger pulse, pulse width, and so on. These are all settings which can be tailored to the needs of the application. Again, talk about that increased functionality and gives pulse lighting a high degree of configurability. So we'll look at what some of these mean in a bit more detail in the next slide. So firstly, we'll look at the pulse width, which effectively is the duration or the length of time or the length of the pulse. This would be measured in milliseconds, and given that probably gives you a bit of context about how short the length of time in which a pulse light is switched on for compared to a constant light illuminator. Pulse intensity, i.e. how bright the light can be pulsed. As we were saying earlier, this can deliver up to around 4 or 5 times more light when compared to an equivalent constant light. The intensity would normally be measured as a percentage of the illuminator's total or maximum power. We have the trigger delay. This determines when the light will initiate after receiving the trigger from the camera. This is usually measured in microseconds. And lastly, the frequency, i.e. how quickly the light can pulse, or the rate in which it can be repeated, measured in hertz. There are other settings you can adjust with a pulse light, but these tend to be the ones which you'll most find or be most commonly configured when using pulse light for ANPR systems. A pulse illuminator will generally come with a preset factory setting, but it's worth pointing out that there is no right or wrong setup. It depends completely on the application. And lastly, just to finish off our section on pulse lighting, another consideration should be the use of multiple pulse imaging. At Raytech, we offer this on a couple of our products under the Polestar range. We have the VCT6, the VTR4 and 6 for anyone who's familiar with Raytech products. We refer to this feature as multipulse. And what it effectively means is that a single illuminator can deliver up to 5 pulses, all at different intensities after receiving a single trigger from the camera. So where we looked at that graph earlier, there was a single spike or a single pulse, but with multipulse, there could be up to 5 after each trigger, depending on what the requirements are. Why would we use multipulse? That's a question you might be asking. So in short, it's to overcome variables. As you can imagine with an ANPR system, there are lots of variables, and altering the intensity of light can effectively provide different images to suit different scenarios. For example, you'll often have vehicles traveling at different distances or being different distances away from the camera and being on different positions on the road, especially when there's multiple lanes involved. You'll have vehicles traveling at different speeds. They won't all be traveling at the speed limit necessarily, so we have to contend with that. And using multiple pulses can even help to reduce the startling effect on road users if you're using visible light. So I don't want to go into this in great detail, but a series of small pulses can appear as continuous illumination with a single high intensity pulse used to illuminate the target without being perceived by the person looking at it. So this just gives you an example again of that increased functionality and the clever thing that you can do with pulse light compared to constant. And again, that just comes back to the opportunities which pulse light can provide. Constant light may well have its use in some systems, but it's certainly worth considering the benefits of pulse light, especially for more advanced or challenging applications. So next, we want to look at some of the specific features of an illuminator that you should consider when you're specifying lighting for ANPR systems. So we're looking at illuminator specs. Before we highlight some of the specific things you should look for, we'll just recap on some of the environmental conditions that your illuminator and its ANPR system is likely to have to withstand. So we mentioned earlier that variable weather conditions can make capturing the plate a challenge, but that can also put a physical strain on the illuminator itself. ANPR systems are deployed globally across different climates, so the illuminator and any other equipment must be able to withstand that. The nature of an ANPR application means that the illuminator will be exposed to wind and vibration from passing traffic. Again, if you consider an illuminator or a camera perched on top of a gantry or a column on a motorway or a highway, there's likely to be very little protection for up there, so it has to be able to withstand the weather conditions it's exposed to. And the illuminator must be able to perform alongside the rest of the system 24 hours a day, 365 days a year, and that's really important because the system is only as effective as the reliability of the components which go into it. So it's really important to find an illuminator which gives you that reliability. So that, with that in mind, what you should actually look for, consider when you're specifying an illuminator. And this is in no particular order, but you should be checking what kind of environmental protection the illuminator has or what's been tested against. Is there any evidence of protection against salinity and humidity if that's necessary? Has there been any vibration testing carried out? What is the IP rating and what's been tested to? And this, of course, the spec that you need to look for will depend on the demands of the application, but these are all factors you need to bear in mind in the context of where you're installing the illuminator in your ANPR system. Critically, who is the manufacturer? Are they a reputable manufacturer? Do they have a track record in traffic and ANPR projects? These are important things to consider. You may well require the support of a manufacturer further down the line, especially for more complex installations. For example, if you're using pulse light, you have to question, is that support available to me? So all really important things to consider around who the manufacturer is. And you should also give some consideration to how the illuminator can or will be controlled and how it will communicate with the rest of the devices which are used in the system. Again, for more complex installations, we'd always recommend an illuminator which is IP enabled, so it can be connected to other devices via an Ethernet connection, which is obviously important if we're looking at an ANPR system with different components which can communicate with each other. Some older systems may still be using an RS-232 connection, but using this over Ethernet may limit performance, reliability, and also the compatibility with other devices on the network on the system. So we would always recommend an IP-enabled illuminator where possible. Moving on to the last section now, we'll just look at some final considerations. Testing may seem like an obvious one, but the importance of thorough testing can't be overstressed. Taking the time to test your setup, not just of the lighting, but the system as a whole, is critical to achieving good images, which are obviously really important to the overall success of the ANPR system. As you mentioned earlier, there's a large number of variables within these type of projects, so you need to try and replicate as many of those variables as possible, test the system out in different weather conditions, different times of the day, with vehicles traveling at different speeds. The more testing that you can be done prior to full deployment, the greater the chance of achieving good, high quality, reliable images of the plate. And finally, it's really important to take a systems-wide approach, which may seem a little contradictory, given that for the majority of this webinar, I've talked only about one element in terms of lighting for the ANPR system. Now, obviously, that is an important element, as we've discussed today, but you should be taking a close look at everything in your system. So your camera setup, any lens or filtering, and of course, any software which is used to process the images once the images have been successfully captured. But the quality of the image is based on a combination of these key optical elements. It's something we discussed in a little bit more detail in our white paper called Lighting for Intelligent Transport Systems. That's available to download from our website, and we talk about the different factors to consider in the Raytec Magic Forma recommended setup for a few different factors as well as just the lighting. So I'd recommend you check that out. As I say, a white paper called Lighting for Intelligent Transport Systems, which is available through the Raytec website. And last of all, I just want to touch on how Raytec can help you with your ANPR needs or projects. So of the things we discussed today in terms of products, we offer a range of constant and pulse lighting solutions. Any of Raytec's pulse lighting products sit under the Polestar range, and any constant light illuminator you'll find under our Vario 2 range. So again, we're impartial in terms of which is best for each system. We can obviously appreciate the benefits of using pulse light, but also recognise that there can be a use for constant light for certain applications too. We looked at the different wavelengths of light, and again, this is something we offer across all of our products. So 850 nanometers and white light, which are the most commonly used. Well, 850 nanometers is the most commonly used for ANPR, but also for white light. We also offer 940 nanometers, which is predominantly for more covert security applications, but something we do offer. The 730 nanometer far red that we mentioned for projects you can see inside the vehicle, again, is something we can help you with. But I think generally speaking, If there's something you need which you can't see, or you're not sure if we help with, come and speak to us, because we are flexible and we love to talk lighting. So please come and speak to us if it's something we can help you with. And lastly, Raytech have many years of experience in designing, testing, delivering solutions for transport projects. Obviously, we've been discussing ANPR today, but that experience also extends to rail projects, to other OCR projects. So please do reach out to us if there's something we can help you on, and we'll do our best to do that. So that concludes the webinar. Thanks very much for your time and attention. Hopefully you found it useful. We do have some time for questions, so please, I can see there's been a couple in, but please get those in now if you do have any. And again, just a reminder, you should be able to do that via the questions section of your control panel where you can type them in. As mentioned, I've got my colleague Ellis waiting in the wing to give me a hand answering your questions if needs be. So we do have quite a few attendees on here today. So if we can't get through all the questions, we will definitely come back to you offline once the webinar's ended. So I may go quiet for a few moments just as I have a read of the questions, but I am still here. So if you bear with me for 2 minutes, I'll then start reading the questions out. So there is one question here from Subash. Hopefully I've said that right, Subash. I might hand this over to you, Ellis. So the question from Subash is, are all cameras, or do all cameras have this feature, which I presume is talking about pulse lighting? So can all cameras be integrated with pulse IR, or only specific cameras?
The answer to that is no. So what you might find is a lot of the security cameras on the market don't have this functionality. So it used to be the case that primarily like the old machine vision cameras would be the ones that you'd go to. Nowadays, there's a raft of ANPR specific ones out there from the likes of Baslar or FLIR, which will synchronize properly, but you'll need to look out for the that specification for that functionality.
Thank you, Ellis. There's a couple of questions asking if the slides will be made available. Yes, we will. We will be making the slides available after this. Like I said, we'll be sending a quick follow-up in the next few days. You'll have a copy of the slides as well as a copy of the recording, so you can watch back in your own time if you like. Just reading through a couple more which are coming in now. So again, I might put this one to you as well. This one's from Phil. Phil asks, at freeway speed, what is the most used type of illuminator, pulsed or constant? Any thoughts on that one?
To be honest, it's totally dependent on the application. We've worked on many projects using both. So, for example, the smart motorway projects that Callum referred to earlier in the UK, which is using hundreds of our lamps, they're all just the standard steady state setups, the Vario lamps. If it's more a case of if you have the ability to use a pulse product, then it's in your benefit to do so, because the power increases that you're going to get, you're able to use a smaller unit. But both are perfectly suitable for kind of like a standard motorway application, with what we would see is fairly standard as a 1/1000 shutter speed on the camera. You've got the ability to use either.
Thank you very much. There's a couple of questions as well, sort of very generically asking, how do I connect a pulse light to my camera? I'll quickly take that one. So I did mention that in the webinar that you do generally need a TTL input to do that. What I would recommend for anyone who has any questions on how to connect your pulse light to your camera, for all our products, we have a Polestar connectivity guide, which is available to download from our website on any product pages. That goes through the different options and the different setups which you can use to connect your camera. So I would recommend anyone who has any questions around that, have a quick look at that, because they'll probably explain a bit more clearly than I can on here. So yeah, the Polestar connectivity guide, which is available to download on any product pages. Another question from Mohammed. Again, Alice might fire this one your way. What is required on the camera side for synchronized pulsing?
Oh, well, it kind of the same as what you've just said there, Callum, in terms of just a TTL input, so that the synchronization can be sent over to the lamp to pulse in sync with your camera shutter speed. So that's purely it. Obviously, after that, you're looking at making sure that the wavelength of light is what you're wanting, whether that be infrared for what we would see as the majority of ANPR applications, but if if you're in a country where perhaps red lettering is used and white light. But in terms of the setup, it's purely just that TTL input, which is the big what if. If you've got that, then there should be no reason that you can't use the Polestar products.
Thank you very much. There's a question from Hero who asked for pulse lighting. How many milliseconds does it take to recharge fully for the next trigger? Here it will depend slightly on the different products in terms of how fast the pulses can happen between each other. But I want to give you a standard answer. It will, like I say, will differ slightly on product. So understand which product you're looking at, we can give you a bit more information on. So we might take that offline with you and send you a bit more information on the different products and the specs of each one. So we'll take that offline with you if that's okay. Which I think answers all the questions for now. So we will hang around for another couple of minutes in case any more questions come in. But for now, I'll just say thank you very much for your time, and hopefully you found today's webinar useful. Just a reminder, as I said earlier, that we will send you a quick follow-up next few days with a copy of the slides and the recording, and possibly a link to a couple of the other resources which I've referred to today as well. So I think all I have to say is thanks again for attending, and hopefully you found it useful. And we'll say goodbye for now. Thanks very much.